derivatives involving inverse trig functions and their compositions. So this first guy, we do not apply this technique to, but notice how it relates to the problem on the right. So this first problem is a simple u sub where we set u to 1 plus x to the fourth and du to 4x cubed dx. We can deal with the 12 and the 4 and sort out what constant needs to be used after going through the u sub. But what is true, or I guess noteworthy about the situation, is the degree 1 difference. You don't see that here. What you do see here is this denominator term, which might make you think a little bit about what we saw previously, where what looks in the denominator is something that resembles the derivative of an inverse trig function, in particular arctangent. So watch what happens if we simply think. I think this is a derivative. I think this is a derivative of some arctangent of some u. I think it's a derivative of a trig, inverse trig function composed with something else. I think that's why that x to the fourth is there. And so to sort that out, all we have to do is set u equal to the square root of that x to the fourth. So we set u equal to the positive square root of that x to the fourth, and that's just going to be x squared. I do that, then I compute my du, and it's 2x dx. Divide both sides by 2, and you have your x dx that you're going to substitute in with 1/2 du. Now, let's see how that rolls. So this is going to be equal to my 1/2 du all over downstairs. It's 1 plus x to the fourth. I don't have an x to the fourth. Well, I do if I just square both sides. I've got an x to the fourth in my u substitution game. So so this denominator is 1 plus u squared. The 1/2 can come out in front, and you should know that the antiderivative of du over 1 plus u squared is arctan of u. So 1/2 arctan, whatever u was x squared plus c. So this is the antiderivative of this x over 1 plus x to the fourth. Similar kind of thing here. On this leftmost problem of the second row, notice that there is a u du relationship. And so it's this kind of substitution that you want to tackle with this problem. But you don't see that kind of problem here. You don't see this this type of u substitution. Why? Well, the natural thing to do might be to set u equal to x squared minus 1, and your du would be this thing multiplied by, it wouldn't be 2x, and this 2x would live adjacent to the radical u, but that is in the opposite side of where this dx lives. It shouldn't be too surprising to you that this u substitution is not going to work for this kind of problem. So instead, what you can think is have I seen this kind of form before? And yes, you have. If you just bring this 5 out in front and leave the 1 there, right? This 5 was the 5 times 1, and the 5 can just come out, leaving you a 1. This is the same thing as just 5 times, what is this, arc secant of x plus c. And I claim that these two problems are fundamentally very, very close. Like what? So notice these two are more closely related because this has the same type of u substitution pattern. This pattern doesn't. So and I claim that when this 2 gets changed to an 8, this alters the problem in a minor way, but a way that arcsecant can still handle. So what happens here is you could set u equal to the square root of that x to the 8. Now, why do you do that? Why do you set it equal to the x to the 4? Well, because when you square that, it's going to be x to the 8. So you can think of this as square root x to the 8 minus 1. Now, if you jump down here and take your du, you're going to get 4x cubed multiplied by your dx. There it is. Now you get your du over 4x cubed. Now that equals your dx. Now watch what happens when you substitute this dx in for the given. So here we go. Radical 1 over. It's very important to know that this x did not get substituted out. It should still remain. The square root also did not get substituted out. It should still remain. That x to the 8 is now an u squared. Minus 1 stays. My dx has now been transformed into du over 4x cubed. This 4x cubed is going to commute via in the multiplication with this radical, producing 1 over 4x to the 4th radical u squared minus 1 du. Now, notice this x to the 4th term. I've seen that before. It's exactly my u. So the 4 can come out in front. So 1 over 4 on the outside, and on the inside, 1 over, not x to the 4th, but u on the square root of u squared minus 1 du, and that's just 1/4 of arc secant of u plus c, which is 1/4 arc secant of x to the 4th plus c. There you go.